welcome to this lectures room. The topic before us today is probability. Probability in mathematics is a topic that has to do with the forms of expectation, and we are going to put it in a form of numerical values to do the calculation of such an expectation. In everyday life, all of us, we do have one expectation or the other. If you want to go for an examination or you want to write a test, you have the intention of either passing the test or not to pass the test, or to pass the exam or not to pass the exam. Also, if you want to go for job interview, you want to buy a car, you are expecting money from somewhere, those your expectation, at times it can come to reality, and at times it might not come into reality. In that case, we will now put those values of whether it comes into reality in a forms of a numerical value. Now, probability, now we cannot define it from those forms of expectation. Now, probability is defined as the measure of result or outcome of expectation in numerical form. The outcome of the result of the expectation that we have is what that is the result that eventually happen. For instance, if I put, for example, now you want to write a test and you are expecting yourself to score an A in the test. You write the test and you eventually score less than an A. So that is the result of the your expectation from the test. So the probability of you getting that is going to be given a value. Or okay, if you score over A, what is the value there? And if you score less than A, what is the value there? Then we'll now do the probability of such an event. In this class, as we continue, you are going to have detailed information about the whole thing that has to do with probability. Now, I want us to also note this thing. If now that you have the result of your expectation has come out, and that result is not in your favor, or if the result is unsuccessful, such probability will have the value to be equal to 0. That is, the probability of an unsuccessful event or unsuccessful result is 0. Now, if the probability of your expectation that you put in place, if it gives you 1, that means that that probability is successful. That is, the probability of a successful event or an expectation is 1. Now, I will know this too. You have the probability of that event not coming into being, and you have gotten the probability of the value that when the event is a successful one. Now, we also need to look at probability of what we call equiprobable event. Equiprobable event happen to be a forms of event that the probability of any of the expectation coming into being is the same. For instance, in the throwing of a coin has an head and a tail. That is the two values that the coins have, a head or a tail. For us to throw a coin, the probability for any one of them to come to reality or to show up is going to be 1/2. It can be any one of them. We are not going to be sure of whichever one is going to come into pass. So whatever that is going to come into being, the such an probability of the expectation that is just 2 for either of them to have the same chance of occurring is called equiprobable probability or equiprobable event. Now, probability can now be defined mathematically as the number of equiprobable favorable outcome divided by total number of equiprobable outcome. That is how you define probability. in the case here now, number of favorable equiprobable outcome divided by total number of equiprobable outcome. That is the definition of probability. As we go on, we can still have different forms of event that can come up and shape the values or the definition of this probability, but it's going to result into the same value. Now, in this class today, we'll be looking at different division of probability. We are going to start from experimental probability. We're going to take a look also at the theoretical probability, after which we'll as well look at the mutually exclusive probability and independent probability. We are going to look at probability as a whole in this class, and I hope you are going to enjoy the class. Do subscribe to our channel, as we are going to be giving you day-to-day information about what we do on our channel. We promise to give you the best on our channel. Thanks. Stay tuned. Sit back, relax for this set of good class for probability. Experimental probability is based on taking of an experiment. For instance, if you as a scientist will perform an experiment in the laboratory, when you perform an experiment, you will be expected to make some observation. Then you are going to have your conclusion, which you are going to put your record down. The same thing happens in an experimental probability. You will be given some values which are going to be based on the past event. Then those numerical values that has been given will be used to compare to the event that you are going to provide the answer for, to make the value for the feature or the result you are going to provide properly. Now, in other words, mathematically, experimental probability can now be given to us as the number of required outcome divided by number of possible outcome. It does not mean that that one has changed the definition of probability, but in experimental probability, it is talking about number of required outcome divided by the number of possible outcome. Let's look at a question on experimental probability. We're going to have some questions there now to back up what we have been talking about. Now, the question we have here is, out of 200 students in a school, we have it that 30 have brown sandal, and the question is now asking us that we should, if a student is chosen at random, that we should what is the probability that a student chosen at random will have a brown school sandal? In this question that we have here, what we need to do is just to have it. Experimental probability is an experimental probability. We have the number of students already. Number of students in the school. Number of students in school is equal to 200. Number of students with brown sandal is what? 30 students wore brown sandal. Now, those number of students that wore brown sandal compared to number of students in the school, that is what we are going. Now, the probability that when a student is chosen at random is going to wear this brown sandal. Look at the number of, now in experimental probability now would now be equal to number of required outcome divided by number of possible outcome, which is equal to, now required outcome is those students that wear brown sandal. That is if you pick one. So you are now going to look at the number of students that wore brown sandal, which is got 30 all over. Number of possible outcome is the value that is given to us as the total number of students in that school. That is 200. If you call this 0, you call this 0. We have the answer to be equal to 3 over 20. These are the probability of if a student is picked at random, that student will wear a brown school sandal. Now, we are going to have some other questions. This question we have here give us a table. As you can see the table here. The table, from the table, the question says that the table shows the weight of the number of students. The number of students that have 40 kilogram weight is, as you can see it here, is 11, while those one with 30 kilogram weight are 9, 25 kilogram weight, those one are 3 in number, 20 kilogram 6, 5, 15 kilogram 6 as well, and we have the 12 kilogram, which is just 5 students. Now, this table we have here, we have a question that you can see underneath it. The first question there says that how many students are in that class or school that we have here. Now, the first question says how many students are here. The first question, let's have the answers here. The question says number 1 now, how many students are there? Now we are going to look at the numbers, and you can see that we have the value for the weight of the student on top, and we have the number of students down. So it's very easy. Just add everything that you have and the number of students there together, then you get the number of students. And we have the number of students to be 11 plus 9 plus 3 plus 6 plus 6 plus 5. So which is going to be equal to 20, 23, 29, 35, which is going to be equal to 40 students. We have 40 students all together in that school. Now, the next question that we have here, the question says, what is the probability if a student is chosen at random? If a student is chosen at random, what is the probability that the weight is 25 kilogram and above? As you have it here, you can see that the students that have 25 kilogram weight, they are 3 in number of students. Now, for those ones that have 25 kilogram and above, we are going to start from that 25 kilogram itself. And the student with 25 kilogram are how many? Those ones are just there are 3 students with 25 kilogram. Those one with 30 kilogram, this is 25 kg. That's 3. 30 kilogram. There are how many students there? 9. And those one with 40 kilogram, they are 11 students. 11 students. So probability that if a student is choosing random, the weight will be 25 kilogram and above. That is a question given to us. Probability of the student pick our weight of 25 kilogram and above will be equal to, what is the total number of students that we have here? We are having 3 plus 9 plus 11, that is 23 over the total number of students. That will be equal to, so now I can now say that the probability of students that have weight of 25 kilogram and above will be equal to students with weight 25 kg and above over total number of students in the school, which is 23 over the total number of students that we have is 40. So that is the answer to that one. Very simple to approach. Now, the next question that we have there says that what is the probability of a student having a body weight less than 20 kilogram? The probability of a student having a body weight less than 20 kilogram, you have to look at the body weight of 20 kilogram. We can see there that those students that have 20 kilogram, they are 6 in number. Now, they say student with body weight less than 20 kilogram. So, which means that you must not include 20 kilo, those ones that have 20 kilogram with it. You have to talk about those that have the weight that are less than that 20 kilogram. So, we are thinking about, according to what we have on the table here, we'll be thinking about those one with 15 kilogram and those one with 12 kilogram. That is what? That's number 3 now. There we go. Probability of 20 kilogram of student with 20 kilogram less than 20 kilograms. Sorry, that's less than 20 kilogram will be equal to, that is going to be equal to number of students with weight of 15 kilo of weight of 15 kilogram and 12 kilogram. Number of students with 15 kg and 12 kg over total number of students, which is going to be equal to, let me have it here, is going to be equal to, what are the how many students have that are in 15 kilogram and 12 kilogram? That's 6 plus 5. 6 plus 5 all over 40. That will be equal to 11 over 40. So those are the number of students that have the weight less than 20 kilogram. And the fourth question that we have here, the fourth question says that, according to what we have here, it says that how many students have a body weight of more than 30 kilogram? How many students have a body weight of more than 30 kilogram? So we are going to look at we are only asked for the number of students here. Don't forget, look at the question very well. You can see that they did not mention what is the probability. So they did not even talk about anything that has to do with the probability there. So we are only asked for the number of students that have a weight more than 30 kilogram. If you look at it from our table that we have here, only 40 kilogram weight is higher than 30 kilogram. And how many students are having that 40 kilogram weight? So that will be what? 40 kilogram weight with student. This number of student is equal to number of students for that 40 kilogram weight is how many? That is 11 students. 11 students. So those are the answer to the question that we are asked. Theoretical probability. Because the experimental probability compare the past with the future, we try to look at the value in that order. Theoretical probability have to come into being because of the lapses that might happen in the experimental probability. Now, theoretical probability have to deal with physical condition, physical nature of the condition or situation that are being considered. When we talk about physical nature or condition that are being considered, we can be talking about events such as tossing of a coin. When you toss a coin, we can be talking about the rolling of a dice. Those are physical things that we can see. And we can as well be talking about selection of object from where they are made. You can talk about selection of different color of balls. If you have to pick a particular balls of a particular color from where we have different colors of the ball, that's what the theoretical probability will be dealing with. And we also have many forms of theoretical probability in that order like that. So we'll be dealing with how we talk about this question of theoretical probability in this class. Dice is tossed once. We have to find the probability that an odd number shows up. If you toss it pair that now, the probability of getting an odd number. Number 2, that 3 is shown, and number 3, a number less than 4 is shown. The number 4, a prime number is shown. A prime number is shown. Now, for you to have in a die, tossing a die now, tossing a single die, we are going to have the result to be 1, 2, 3, 4, 5, 6. That is when you toss a single dice. Now, if a single dice is tossed, now the probability, the first question here, probability of odd number. Probability of odd number, of you getting an odd number, will be equal to what now? What are the odd number that we have here? That's what? That's going to be odd number over total number shown. That'll be, now the odd number we have here will now be what? Will be R, 1, 3, and 5. The odd numbers there are 1, 3, 5. All over. What is the total number shown that you have when you toss a single die? 1, 2, 3, 4, 5, 6. That's 6. So that will be equal to what? 1 to 3, 3 over 6. So the answer is equal to probability of odd number is equal to 1 over 2. When you call this, you get 1 over 2. Now, the second question that we have here, the question says that we should find the probability of obtaining a 3, of obtaining just a single 3. So we can see that we only have one 3 here. That will be what? Probability of 3 is equal to what? How many times do you have 3? 1 over 6. That is the answer to that question as well. Now, the next question says that what is the probability that a number less than 4 is gotten? Probability of number less than 4 will be equal to, when you talk about number less than 4 here now, you'll be talking about 1, 2, 3. It's those are the numbers that are less than 4. So that will be 3 numbers. 3 over the total number that we have there, 6. That will be equal to 1 over 2 as well. That is 1 over 2 as well. Then for the last question, that's number 4. The question says that the probability of having a prime number. Now, I have to let you know that the values of the prime number, the meaning of prime number, even number, odd number, you must make sure that you know them very well so that you'll be able to answer questions that has to do with probability. Even when you are dealing with set theory as well, you need to also have all this information at the back. Like even all the information such as natural number, fractions, factors of any value of any forms of numbers, they are very, very important. So you need to have them at the back of your mind to make use of them. Now the last question says the probability of obtaining a prime number. When you look at it here, what are the prime numbers that we have here? We know that prime numbers are numbers that are what divisible by 1 and itself. So, but 1 is not part of prime number. So we have 2, 3, 5. So probability of prime number, or that's what? 2, 3, 5. Those are the prime numbers over total number. That's what? 3 over 6. That will be equal to 1 over 2. Yes, those are the prime numbers. You can see that the difference between the odd number and the prime number. Prime number has 2, 3, 5. 2 begins with prime number. Prime number begins with 2. While odd number starts with 1. Go and check the meaning very well for you to be able to have very your confidence when you are trying to solve question as regard probability and any forms of question in mathematics. The question is given from this table here. The question says that if a number is picked at random, the first question says what is probability that 1 it is a number divisible by 2. The second one says it is an even number. The third one it is a perfect square, and the last question says that the number that is more than 15. So let's look at the first thing we need to do here is we have to look at the total number of the numbers that we have in this table here. Total number now. Total number in the table will be equal to, if you count together, we are having 20 numbers. We have 20 numbers now. For the first question, probability of obtaining a number divisible by 2 will be equal to, now the first thing we need to know here is the numbers divisible by 2. We have to pick them out. Number divisible by 2 are, from the table we have there, we have 4, 6, 8, 12, 20, 14, 6, 24, 20. If you count the number very well, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have the 4, 6, 8, 12, 4, 6, 8, 12, 20. We have 16 before that, 20, 12, 16. So we have to count the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, probability of number divisible by 2 will be equal to what? Number divisible by 2 by 2 all over total number on the table. So probability of number divisible by 2 will be equal to, what is number divisible by 2? That's 10 over 20. That's total number we have here. That'll be 1 over 2. That's probability of number divisible by 2. We have been able to deduct the value of number, total number that we have there. Now, the second question says that probability of obtaining an even numbers. Let's look at the even numbers that we have there. Even numbers are, that will be, we have the 4, 6, 8, 12, 16, 20, 14, 6, 24, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We also have 10 numbers. So probability of even number will be equal to the number even numbers, that's 10 over total number in the numbers. We have it to be equal to 1 over 2. 1 over 2 as well. Now, for the third question. The third question says that we should find the probability of picking a number that is a perfect square. What are the perfect squares we have there? So let's first of all bring out the perfect square. Perfect square. The perfect square we have in the table here are 4, 9, 16. 4, 9, and 16. Those are the numbers that the value that you multiply with one another will give it list to them. If you say 2 times 2, you get 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 16. Those are called perfect square. Now, so those are now probability of perfect square now. Probability of perfect square will be equal to, how many numbers do you have there? 3 over 20. 3 over 20. That is the probability of obtaining a perfect square when the number is picked at random. Now, numbers that are more than 15. That's the fourth answer. Numbers, probability of obtaining numbers more than 15. So numbers more than 15 now. Numbers more than 15 will be equal to, that is 16, 19, 20, 24, and 24, and 20 again. How many numbers? 1, 2, 3, 4, 5. According to the table, those are the numbers we have there. So now probability of obtaining numbers more than 15 will be equal to, how many numbers? 1, 2, 3, 1, 2, 3, 4, 5. 5 numbers, 5 over 20, which is going to be equal to 1 over 4. Those are the answer to the question that we have here with the table there. More questions as the survey show that 15% of a student in a school are tall. Then the question go further to say is that if a student is chosen from a class in the school, what is the probability that the student is short? Now, let's go to the answer proper. 15% of students in school are tall. We are not given the number of students in that school properly. So we can now say that 15. So the tall students, percentage of tall students, which has been given to us, is equal to 15 over 100. 15%. Now, percentage of short students will be equal to 100 minus, because the percentage is always run in 100. 100 minus 15, that'll be 85%. So, percentage of short student will be equal to 85%, which is equal to 85 over 100. If you divide this, 5 here, 1, remain 3, 5 in 35 is 7, all over 5 here, 2, 5 here, 0, 20. So that is the answer. So if a student is picked at random, the probability that the student is going to be a short student is 17 over 20. In this class, we are going to consider under probability the mutually exclusive event and that of an independent event. Now, when we say an event is mutually exclusive, it means such an event is an event that only one out of the particular set of events given to us can occur, can be able to show. It cannot come alongside with the other one at the same time. For instance, if I throw a coin, it is only head or tail that can come out from that particular throwing of a coin. The two of them cannot come out together. So I can only pick one of them as the particular probability I'm going to work on. The same thing applies to when you are talking about the probability of throwing of a dice. When you throw a dice, it is either you get any one of the 6 numbers that are of the sides that's going to come out. So any of the 6 numbers that come out can only show at once when you throw a single die. It will come once, and once that one shows up, another one cannot as well show up at the same time. Now, this case, I can now take it to our normal life event. Now, for instance, it is not possible for you to spit at the same time you now whistle with your mouth. That is not going to be possible. So you have to do one, then leave the other. So in this case now, that is how we meant by mutually exclusive event. That is an event that can only come out by itself alone. Now, in mutually exclusive event, we are going to be looking at some particular words that are common to those mutually exclusive event. Words like either or, neither nor. When you have such a word shown in a probability, you are going to make use of addition of those probability. For instance, if I gave you a particular question and say either probability of either A or B, it means probability of A plus B. You are going to, whenever you see either or neither nor, you have the two events together. Now, that is mutually exclusive event. Now, in independent event, now this is the occurring of two events without affecting each other. When you see two events that occur together without them affecting each other, you call such an event an independent event. And in independent event as well, the common things that are common terms that we'll be making use of in independent event are a word like and, both, all. Such a word, when it comes up in independent event, whenever you see probability of A and B, probability between all the terms. It means that by the time you want to translate what you have in your mind, you are going to say A and B and C and D. You are going to make use of multiplication of such probability with one another. For instance, if you are talking about probability of A and B, you will say probability of A multiplied by B. That is what is meant by independent probability. That is what I mean by independent probability. Now, we're looking at some questions as regard this mutually exclusive and that of independent probability. The question we have here is going to give us a very good insight into probability of mutually exclusive probability. Now, the question reads and says that from the integers 10 to 25, both number inclusive. What is meant by that is that 10, 11, 12, 13, you have to mention 10 alongside the numbers you are going to. So the numbers that we have there, numbers are 10, 11, 12, up to 24, 25. Those are the numbers that we have there now. Now, they are inclusive. Now, the question now says that if a number is picked at random, the probability of obtaining, question is probability of obtaining prime number or even number. Now, what we need to look at there is that let's firstly bring out those numbers that are prime number. Then after we've done that, we'll be able to bring out also those numbers that are even number. The prime numbers are now, that's the prime number will start from, that is going to be 11. Don't forget what is meant by prime number. Prime number are numbers that can be divided by 1 and itself. 11, 13, 17, 19, then 23. We are having how many numbers here? 1, 2, 3, 4, 5. We have 5 numbers. 5 numbers that are prime number. Then the even number. Even numbers will be, what are the even numbers we have there? 10 inclusive, 10, 12, 14, 16, 18, 20, 22, 24. Don't forget what is meant by even number. The numbers that can be, that are multiples of 2. Those are the numbers that are called even numbers. Now, how many numbers do we have here? Those are 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. Now, we also need to know the total number from the figure given to us. We are given the integers. I think these are positive integers from 10 to 25. And the total numbers that we have between those numbers are 16 numbers. 8 numbers, 16 numbers. Now, we need to find the probability of prime number. Then we also need to find the probability of getting the even number before we go into the conclusion of our solving the question properly. Now, probability of prime number now will be equal to, how many number do you have there? That's what? Prime number of prime, number that are prime, all over total numbers. That's 5 over, what's the total number you have there? 16. 16. That is the answer there. Now, probability of even number will be number that are even numbers over total number given to us. Now, the even number we have there, how many of them? 8 all over 16 numbers. That's the total number. That's 1 over 2. Now, we can now solve for probability of picking either prime number or even number will be equal to, that's 5 over 16, or in mathematics, it means, in probability it means or means addition, and 1 over 2. Or means addition, where and, as I've told you earlier, and means multiplication. So we are having what here? What is the LCM? We have to find the LCM because we are having addition separating the fraction we have here. This is 16 is the LCM. This will be equal to 5 plus 2 in 16 is 8. 8 times 1 is 8. That will be equal to 8 plus that 13 over 16. 13 over 16. That is a probability of picking the number that is either a prime number or an even number. Now, in a case whereby the question goes in this form, that probability of picking a prime number and an even number. Prime number and even number. Now, probability of prime number and even number will be equal to 5 over 16 multiplied by, I think I have this one separately, multiply by 1 over 2. So which will be equal to 5 times 1 is 5 all over 16 times 2 is 32. You can see that we make use of or in the first value. That is an mutually exclusive event when we make use of such an expression. Whereas in this one that we just found, which is not part of the question given to us, we make use of and there. It is an independent event. So that is how we do the calculation in that order. Small question still comes stating